What if a single wavelength of light could tell your skin cells to rebuild themselves? The process is called photobiomodulation, PBM for short. Non-ionizing light at precise wavelengths triggers measurable biological changes inside living cells without generating damaging heat. The sweet spot sits between 630 and 850 nanometers, the red and near-infrared band. Below that, the skin absorbs too aggressively. Above it, the light passes straight through without interaction. Human skin has three main layers: the epidermis on top, the collagen-rich dermis beneath it, and the subcutaneous fat below that. Red light at 630 nanometers penetrates roughly 2 to 3 millimeters deep into the dermis. Inside the dermis live fibroblast cells, the factories that manufacture collagen. Inside those fibroblasts sit mitochondria. That's where the red light story gets strange, and stranger than most skincare brands will tell you. Mitochondria contain a protein called cytochrome C oxidase, CCO. It's the terminal enzyme in the cellular energy chain, and it absorbs photons in the red and near-infrared range with remarkable specificity. When CCO absorbs a red light photon, it accelerates ATP production, adenosine triphosphate, the cell's primary energy currency. More ATP means the fibroblast has more fuel to do its actual job. A fibroblast, flush with ATP, ramps up collagen synthesis, specifically type 1 and type 3 collagen, the structural proteins that give young skin its firmness, bounce, and that infuriating plumpness we all miss. Here's where it gets counterintuitive. PBM also triggers nitric oxide release, dilating blood vessels and boosting local circulation. Researcher Tina Karu documented in 1989 that a single red light exposure can double mitochondrial membrane potential within minutes. The clinical story of PBM started not in a spa, but in NASA laboratories in the 1990s. Researchers growing plants in space with LED arrays noticed that red light at 670 nanometers accelerated wound healing in crew members' skin abrasions. The deeper roots go to 1967, when Hungarian physician Dr. Endre Mester accidentally discovered that low-power ruby laser light stimulated hair regrowth in shaved mice. He called it laser biostimulation, the conceptual grandfather of every red light mask sold today. Early clinical devices used actual lasers, expensive, clinic-only, and occasionally alarming. The shift to LED arrays in the 1990s democratized the wavelength. LEDs deliver the same photon energy at a fraction of the cost and zero coherence requirement. Here's the counterintuitive part. Near-infrared light at 830 nanometers is invisible to the human eye, yet it penetrates deeper than visible red at 660 nanometers. Longer wavelength, less scattering, deeper reach, which is why premium devices combine both bands. Dose matters enormously. A 2014 review by Hamblin and Huang at Harvard Medical School confirmed a biphasic dose response. Too little light produces no effect, optimal light stimulates, and too much suppresses cellular activity. More is not better. The biphasic curve exists because at high fluence, PBM overloads the mitochondria, generating excess reactive oxygen species, ROS. Small amounts of ROS are beneficial signaling molecules. A flood of them triggers cellular stress and inflammation instead of repair. In a 2014 randomized controlled trial published in Photomedicine and Laser Surgery, subjects using 633 nanometer and 830 nanometer LEDs for 12 weeks showed statistically significant reductions in periorbital wrinkle depth and improved skin elasticity scores. Compare that to topical retinoids, the gold standard of anti-aging skincare. Retinoids also upregulate collagen production, but through a different pathway involving retinoic acid receptors. PBM and retinoids aren't competing. They work on separate mechanisms. PBM does something retinoids don't. It downregulates matrix metalloproteinases, enzymes that degrade existing collagen. Think of them as tiny scissors constantly cutting your scaffolding. Red light tells those scissors to stand down. Here's the question the marketing never answers directly. Do consumer LED masks deliver the same irradiance as clinical panels? Usually no. Clinical devices output 10 to 200 milliwatts per square centimeter. Most consumer masks sit below 50. Lower irradiance doesn't mean useless, it means longer sessions. Joules delivered equal power multiplied by time. A weaker device used for 20 minutes can match a stronger one used for 5, assuming wavelength accuracy holds. South Korea has led clinical adoption. A 2007 study by Lee and colleagues in dermatologic surgery found that 830 nanometer LED treatment after ablative laser resurfacing reduced recovery time and erythema scores by roughly 50% compared to controls, results that drove rapid clinical uptake in Seoul by 2008. Biopsies confirm the mechanism isn't cosmetic illusion. A 2003 histological study by Weiss and colleagues showed measurable increases in pro-collagen type 1 mRNA expression after LED treatment, meaning the cells weren't just behaving differently, they were transcribing new collagen instructions. PBM also modulates inflammatory cytokines, specifically reducing interleukin-1 beta and TNF-alpha, two key drivers of chronic skin inflammation. That chronic low-grade inflammation, sometimes called inflammaging, is one of the primary accelerators of visible skin aging. Contraindications exist and matter. PBM is not recommended over active cancerous lesions, for people taking photosensitizing medications, or directly over the thyroid gland. Eyes require protection. Even LED panels can cause retinal stress at close range. Consistency is the variable most users underestimate. The Weiss 2003 trial used 9 sessions over 5 weeks. The 2014 photomedicine trial ran 12 weeks. Single sessions produced transient effects. Collagen remodeling requires repeated signaling over months. Ultraviolet radiation damages collagen by activating those same matrix metalloproteinases PBM suppresses. Red light doesn't replace sunscreen, but it addresses downstream damage that SPF alone cannot reverse. That opening image, someone reclining under a glowing red mask, looking suspiciously unbothered, isn't vanity theater. That's cytochrome C oxidase absorbing photons, ATP surging, fibroblasts mobilizing, and matrix metalloproteinases standing down, all simultaneously. Not all devices are equal. When evaluating a red light product, 3 specifications matter: verified wavelength output, not just color, published irradiance in milliwatts per square centimeter, and FDA clearance or CE marking confirming safety testing was performed. The skin application is just the most visible entry point. A 2021 clinical trial by Saltmark and colleagues at the University of Toronto tested The wellness industry has seized on PBM faster than the research can validate every claim. The collagen and anti-inflammatory mechanisms are documented, but in 2019, the FDA sent warning letters to multiple companies marketing red light devices as treatments for obesity. Claims unsupported by any peer-reviewed trial at therapeutic irradiance. One last fact worth holding: the same hormetic principle governing PBM, where a small stressor produces a beneficial response, also underlies exercise, fasting, and cold exposure. Red light isn't magic, it's a precisely calibrated biological nudge, and the dose curve is everything. Your takeaway: if you're buying a red light device, demand the irradiance number in writing. Because a wavelength without sufficient power is just a nightlight, and your fibroblasts deserve better than ambiance.